Hello everyone and welcome to most likely the last video in segments and midpoints in 4-1. We are still on page 43. We're going to go ahead and look at number 14 here. So when you bisect a geometric figure, you divide it into two equal or congruent parts. Okay, so to bisect something means you basically cut it in half. Line segment WZ bisects, so let's take a look over here. Line segment WZ bisects XY at point Z. Okay, so let's draw this out. The line segment we have here is XY. Right, so we have XY, and it's telling us that WZ is a line segment that bisects it. This is XY, WZ is a line segment, and this line segment can be basically anywhere. The only thing we have to make sure is that there's this point Z that is part of this line segment, WZ, and what it does is, and sorry, this is point Z, and it cuts this in half, okay? So that's basically what they're saying here. Now again, this line segment could really be any direction. It doesn't have to come in it that way. It could come from underneath. It doesn't matter. What matters is that it has points W and Z is the one that cuts X, Y in half. So what are the two conclusions we can draw? So one of them is that Z is the midpoint of XY. So that's the first conclusion we can draw. If it bisects XY, that means it cuts it in half. That's one conclusion. And then the other conclusion we can draw is that when it cuts it in half, it makes these two congruent line segments. XZ and ZY are going to be congruent to each other. Right? So XZ being this segment, ZY being this segment, those two are going to be the same. They're going to be congruent to each other. Okay, so that's kind of just showing you that bisect is similar to saying midpoint. Bisect is anything that kind of cuts a figure into two equal parts. In this case, Z is a bisector, which happens to be a midpoint. So they're kind of similar, but a little different at the same time. A midpoint is always a bisector, but a bisector is not always a midpoint. It could be, with angles or with something other than just a line segment. So just a heads up. All right, so let's take a look at the next page, page 44. We're going to do these check your understanding. These are going to be similar to the exit ticket questions, as will the check your understanding from the first video. So make sure you take a look at those when you're doing them. Also, the second video, right? So this first, second, and fourth video all have check your understanding, which will be part of your exit ticket. So go back and check those out if you get lost. 15, explain how to find the distance between 2 points on a number line. So remember, you take, subtract the two endpoints. And then, so we'll call that step 1, subtract those two endpoints. Step 2, take the absolute value of that difference. All right, so you subtract the two endpoints, whatever that difference is, you take the absolute value, and that was what we did here. Right, number 11, we subtracted the two endpoints, -3 and 4, and took the absolute value. Didn't matter what order you subtracted them, since you're taking the absolute value. If you weren't taking the absolute value, the difference, the order of what you subtract doesn't make a difference. All right, so that's 15. 16, Mackay knows that GH is 7, HJ is 7. Based on the information, he claims that point H is the midpoint of GJ. Is it true? Maybe, maybe not. So if I wanted to draw this, I could kind of draw it like this. right, where I have G and then J with H, and this is 7 and that's 7. And you look at this and you're like, yeah, dude, H is definitely the midpoint. And maybe, but it doesn't say that G, H, and J are collinear, meaning they're on the same line. So I could also interpret this to be something like this, where I have G and H, and that's 7. And then I have H and J going this way, and that's 7. H is no longer the midpoint of GJ. Right? In this second picture, GJ is this red line, and the midpoint would be somewhere there. So no, this is not necessarily true that H is the midpoint. It all depends on how you drew it. If it had said G, H, and J were collinear, meaning they're on the same line, then yes, 100% H is the midpoint. But no, in this case, not necessarily. It doesn't have to look like that one. So since it's not always going to look like that one, then is it necessarily true? Nope. And I just explained why. All right, given T is the midpoint of JK, and it gives us some other stuff. So let's go ahead and just draw this out and then move it somewhere else. So again, we got a line. So what they're telling us is that T is the midpoint of JK. So JK are the endpoints. T is the midpoint. So I know that the tick marks can go in because those are the same length. JK is 5x minus 3, and JT is 2x plus 1. So I'm going to put in JT first. And then JK was 5x minus 3, so I can label that. And let's go ahead and move this. I'll put it over here as a reference, and I'll also do all the work somewhere over here. This is number 17. So 17. Oops. Okay. So the first thing I would do is I would label the two halves as being the same. Right? JT is 2x plus 1. TK is also 2x plus 1. That's why we put the tick marks in. That's what makes it being a midpoint is relevant. So now I know that the two halves, 2x plus 1 and 2x plus 1, are going to add together to equal the whole. Right? Two halves add to a whole. Once I set up that equation, then it's just a matter of solving it. Again, I can add the two like terms together. In this case, the x's are like terms. 2x plus 2x is 4x. And the 1's are also a like term. Plus 1 is plus 2. And that's going to be equal to the whole length of JK, which is 5x minus 3. Again, I then am going to get the x's on one side, so I could subtract 4x on both sides. That'll turn to 0 on the left, which will leave us with just that positive 2. And on the right, 5x minus 4x is 1x, or just x, and then that minus 3 didn't change, so I can go ahead and add that to the other side, and that gives me x equals 5. Now, while we know x, that's not what they ask, right? They want the length of JK, right? They want to know, hey, what does JK equal? So again, you're going to take JK, which is 5x minus 3, and plug that x in. So 5x minus 3 becomes 5 times 5 minus 3, which is 25 minus 3, which is 22. So JK equals 22. Again, if you wanted to check, you could. You can plug the 5 into 2x plus 1, which gives you 11. If each half is 11, 11 and 11 is 22. So I just did that super quick check. Didn't even write it down. That's just something you can do in your head. All right, so this was number 17. 18. AB lies on a number line. The coordinate of A is -6. So let's make some random number line here. And they tell us A is -6. So I'll go ahead and put A in here. It doesn't really matter where I put it. I put it in the middle because I don't really know where I'm going from here, so I want to make sure I have room. AB is 20. So we want to know the two possible coordinates for B. So you could go from A and go to the right to find B. If you're going to the right, you would add the 20. So -6 plus 20 would give us 14. So that's one possible coordinate. So what are the two possible coordinates? 14 or, and then I could also go in the other direction, and instead of adding the 20, I'm going to subtract the 20. So, -6 minus 20 would bring us to -26. So B can be either one of those coordinates, 14 or -26. Okay, that ends it for this section. If you have any questions, just reach out to me. Again, the exit tickets are going to be similar to the Check Your Understandings in videos 1, 2, and 4, so make sure you go back to those if you need help.